So today's session, our topic is Module 5, that is graphs. Today's session, we will be discussing certain basic topics or basic terminologies related to graphs. So we'll be seeing that. Now first we will see with the definition of graph. What is a very important thing needed in a graph? Important thing is vertex. Why? Because whenever you try to represent a graph, we will think of nodes. Certain nodes will be there, certain connections will be there. This is what a common terminology or common representation of a graph in a computer language. This is how we represent. So we should know what are the terminologies in the graph. So very important thing that node whatever we represent, that is known as a vertex in a graph. So this is known as a vertex. A vertex is a synonym for a node. Whatever the node we write, whatever, for example, we consider this node. For example, them 2 to 4 systems are connected each other. One system is known as one node. Another system is called as one node. Like that, computer is considered as one node. Okay. And when we represent here in a normal graphical representation, the node will look like this, just a circle and write the name of that. So that is known as a vertex. Vertex is a synonym for a node. A vertex is represented just by a circle. This is very important. Vertex is represented by circle. For example, I will take example 1, 2 and 3. Look here. 1 is written in one circle, 2 is written in one circle and 3 is written in one circle. These are known as vertices, or these are also known as nodes. 1, 2, 3 are called as vertices. Now I have written vertices like this. I need to connect them. Now I need certain connections from 1 to 2, 1 to 3, 3 to 2. Like this I need to connect. How to connect a graph? So there is one terminology known as edge. An arc or a line joining two vertices. That is, for example, you take as a vertex U and an destination vertex as V. We will consider this as source and destination. So you take two vertices, either U or V, 1 and 2, draw a line between them like this. Draw a line between them. This line is called as an edge of a graph. So the circle thing, whichever you write, that is known as a vertex, and the line which you draw between those two vertices are known as edge of a graph. A graph can have n number of vertices, n number of edges. Okay. So, and then when it is an edge, for example, in edge, you have two different types of edges, that is undirected edge and directed edge. What is this undirected edge? There is no direction between two vertices. You'll have two vertices and there will be no any direction. That is, there is no any arrow mark between them like this. There is no any direction between the vertices. That is known as undirected edge. That is, one can travel to two and even two can travel to one. That is known as undirection. One person can go to that end and even that person can come to this end. That is one. That is known as undirection. Denoted by an order pair, always the vertices with the edges will be represented like this with an edge 1 comma 2. For example, you have 3 and 2 like this. I have edge between 3 and 2, that is represented as 2 comma 3. Like this we have to represent. Okay, this is known as undirected edge. And for example, there is an vertices and you have certain edge that is having an arrow mark like this. That is known as a directed edge. So the direction exists between, that is an arrow mark, or the direction exists between two vertices. That is known as directed edge. For example, now 1 and 2, there is a direction from 1 to 2. In undirected edge, there is no direction. Now that is, 1 can go to 2, 2 to go, 2 can go to 1. But here when you have a direction, 1 can go to 2, but 2 cannot come back to 1. That is very important when you have directions. The denoted, that is directed pair, is always represented using this two braces. That is, undirected edge is represented by small braces and directed edge is represented by greater than and greater than, lesser than symbols. You have to write the name of the vertices, where one is called the tail of the edge. This is very important. This is called tail, and the tail of the edge, and this is 2. 2 is called the head. This is known as head of the edge. This is tail and this is head. So when you have a directed graph, you should represent them with this greater and lesser symbol. And if there is a direction from 2 to 1, for example, there is a direction from 2 to 1, same you can represent it as 2 comma 1. Okay, if there is a direction. If there is no direction, you cannot represent 1 and 2 and 1 are not at all same because it is a directed edge. Okay, that is one. Now, very important definition of a graph. Formally, a graph G is defined as a pair of two sets. Why? Because a graph consists of vertices and edges. Like this, look here, one graph is there. It is a collection of vertices and edges. So we'll call it as defined as a pair of two sets of vertex and edges denoted by G is equals to V comma E. This is what a graph. Graph is denoted by G is equals to V comma E. You have to represent a pair of vertices. That is, you have to represent a set. This is known as set. Okay, V comma E. Now, V is a set of vertices and E is a set of edges. This is known as a graph. For example, we will take one example, 1, 6, 2, 5, 4, 3. There is a there is a connection between all these vertices and there is a direct connection. Look here, there are certain arrow marks, so that is they are directly connected. These edges are directly connected. This graph is directed graph. Okay, now we have to write V is equal to how many vertices are there? 1, 2, 3, 4, 5, 6. Like this, we have to write the vertices and we have to write the edges. Since this is a directed, we have to write the edges within this greater and lesser symbol. So now 1 comma 2 there is one edge, then 1 comma 6 there is an edge, 5 comma 6 there is an edge, then 6 comma 4 there is an edge, then 5 comma 6, 2 comma 3, like this from where to where the direction is traveling. Now look here, 1 to 6. There is edge from 1 to 6, not from 6 to 1. So you have to write 1 comma 6. There is edge from 1 to 2. You have to write 1 comma 2. There is an edge from 2 to 3. You have to write 2 comma 3. Like this, vertices and edges are written. And you can write total number of vertices are 6 and total number of edges are 7. Always in a graph, edges will be that is 1 plus vertices. That is, number of edges will be always greater than vertices. That is, V plus 1 edges will be there. That is more than vertices, the edges will be there. So here number of vertices are 6, number of edges are 7. This is one simple example of a graph. Now we will see directed graph and undirected. We have seen directed edge and undirected edge. Now we will see what is directed graph and undirected graph. A graph G, B, comma E in which every edge is directed is called a directed. That is, every edge will be having an arrow mark. Look here, there is one arrow mark here, 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 here. They are all directed. That is, every edge is directed is called a directed graph. This is also called as digraph. This is also called as digraph. Now we will see the example. This is one example. We have to list the set of vertices V 1, 2, 3 and 4. 1, 2, 3 and 4 are listed and edges. So when it is a directed graph, you have to write that is greater symbol and lesser symbol. So 1 to 2 there is an edge, so 1 comma 2. 3 to 1, so 3 to 1 there is an edge, that is 3 comma 1. 2 to 4 there is an edge, 2 comma 4. 4 to 3 there is an edge, 4 comma 3. Then 2 to 3 there is an edge, that is known as 2 comma 3. So these are the set of vertices and edges of a directed graph. Now, what is undirected graph? And when you compare with directed and undirected will be having more number of edges compared to directed graph. How we will see that? Now look here, what is undirected graph? A graph G equals to V comma E in which every edge is undirected. It is known as undirected graph. That is, look here, this is one graph. There is no arrow mark on any of the edges. As we saw this, look here, this is undirected edge. There is no arrow mark. The same thing, a graph written using undirected edge is known as undirected graph. Now list all the vertices 1, 2, 3. Now list the word edges. Look here, edges will be more. That is 1 to 2 there is an edge. Again 2 to 1 there is also an edge because you can even travel from 2 to 1. 1 to 3 there is an edge. Even 3 to 1 is also there is an edge. Look here, 3 to 1. 2 to 3 you can travel. Even 3 to 2 also you can go back because there is no any direction. So number of edges will be more in undirected graph compared to directed graph. Okay, this is very, very important terminology of a graph. Then we have self-loop. What is this? A loop is an edge which starts and ends on the same vertex. For example, look here. there is one graph over here. I'll write a loop over. I will write an edge with this itself. So it will start at one and ending at the same. That is known as self loop. For example, you take here this one. You have one here. I will write a directed graph like this, like this. This is a self loop. That is, one is having a loop for itself. One is starting at the same end and ending at the same position. That is known as self loop. Then complete graph. A graph G V comma E is said to be complete graph if there exists an edge between every pair of vertices. Look here, there is a complete graph, that is every pair of vertices there will be edge. That is, one should be, for example, I take one is connected to 4, one is connected to 3, and again one is also connected to 2. There should be a connection from one vertex to all other vertices. That is known as a complete graph. Now you take 4, 4 is connected to 1, 4 is connected to, now you take 4, 4 is connected to 1, 4 is connected to 2, 4 is again connected to 3. So now from 4, all of the remaining vertices there is a connection. You take other graph, you take 2, 2 is connected to 1, 2 is connected to 4, 2 is connected to 3, except 2. Apart from itself, it is connected to all other nodes. This is what a complete graph. A graph which exists edge between every pair of vertices. For a complete graph with n vertices, there will be n into n minus 1 edges. This is very important formula. How many edges are there for a complete graph is n into n minus 1 divided by 2. For example, now how many vertices are there? 4 vertices. That is 4 into 4 minus 1, 3 divided by 2. So 12 divided by 2, 6. Look here, 1, 2, 3, 4, 5, 6. 6 vertices are, 6 edges are there in this example. Next one is path. A path is denoted using a sequence of vertices and there exists an edge from one vertex to the next vertex. That is what path. That is like an edge. That is, path is a distance. That is a direction from one vertex to other vertex. We take it as some source to destination. And there is a certain road. For example, you consider you need to travel from one city to another city. You go by roadways. You'll take the source. That is you'll start from one city and you will end with another city. That is destination. That wherever you are going, on the way you are going, that is known as a path. Here also in graphs we take the path. Now look here, the path from vertex 1 to 4 is denoted by 1, 2. For example, now I will take this as a starting city. Okay, I have to go to ending city 4. How can I travel from 1 to 4? Directly I can travel from 1 to 4, or I can come from 1 to 2, again from 2 to 3, again from 3 to 4 I can go. This is one path for me. Like this, the way you are traveling from one source to destination through other vertices, that is known as a path. The path from vertex 1 to 3, this is a directed graph. A path from vertex 1 to 3. So you now look here, from 1 to 3, how you can travel? You can directly travel from 1 to 3, or else you can come from 1 to 4, again from 4 to 2 you can come, again 2 to 3. So this is the destination. You can come in this way. Or if you don't want, you can come directly from 1 to 2, again 2 to 3. Like this, you have some number of destinations. That is, number of different paths will be there. But we will consider the shortest path when we are doing in our program. So we will see which one is the shortest path and we will consider. Now look here, when you come consider this path, 1 to 4, 4 to 2, 2 to 3. The path is very big. So I will not consider this. So I can consider this as a single smallest path. Okay, then simple path. A simple path is a path which all vertices except possibly the first and the last are distinct. For example, what is this? We'll see. In a graph, the path 1, 4, 2, 3. Look here, 1, 4, 2, 3 is a simple path since each node in a sequence is distinct. That is, whatever you're traveling from source to destination, all nodes appear at least once. Only once they are appearing. That is known as a simple path. For traveling from 1 to 3, you can travel from 1 to 4, 4 to 2, 2 to 3. Like this, all nodes are appearing only once. Now look here. Here when you go 1 to 4, 4 to 2, 2 to 3. This is a simple path. Like this, all nodes in a sequence is distinct. That is, they travel, that is, they appear only once. That is known as a simple path. Then we have length of path. Number of edges in a path gives the length of the path. Number of edges. For example, in this example, how many edges are there? 1, 2, 3, 4, 5, 6. So 6 edges are there. If you consider, that is length of a path. For example, I'll travel from 1 to 3. So I'll go from 1 to 4, then 4 to 2, then 2 to 3. How many edges I'm covering? 1, 2 and 3. That is what the length of the path. Now look here. 1 to 4 I am coming, 4 to 2 I am coming, then 2 to 3 I am coming. How many edges I am covering? I am covering only 3 edges. So I have written 3 here. That is the length of the path. Then we have connected graph and disconnected graph. A graph G is directed or undirected. You can take either directed or undirected. It's said to be connected if and only if there exists a path between every pair of vertices. Now look here. There is a path between every pair of vertices. There will be an edge. One is connected to 4, one is connected to 2, one is connected to 3. Or there will be edge between each and every pair of the vertices. That is a connected graph. Now look here. In this directed graph, there is a connection from 1 to 4, 4 to 3. Either one or the node, they are connected between each others. So that is, there is a connection between the vertices. That is known as connected graph. What is this disconnected? Now look here, a graph G is disconnected if there exists at least one vertex in a graph that cannot be reached from other. Now look here, there is a vertex, there is a graph. Now look here, there is a graph. For example, I'll take this graph. This is 5. Now look here, there is no any connection. 1 is not connected to 5, 4 is not connected to 5, 2 is not connected to 5, 3 is there is none of the vertices are connected to this. So this is disconnected. G5 is entirely different from other graphs. So this is entirely different, and that graph is known as disconnected graph. Okay. And here when you take, for example, here I should write one more node here. I'll write one more node. Then now this is also a disconnected graph because none of the nodes are connected to this. For example, if there was a connection between this and here, for example, there was a connection from 4 to 5. This would have become a directed graph, sorry, connected graph. But there is no connection here. 4 to 5, there is no connection. So it is known as disconnected graph. So these are the certain terminologies related to graph, and based on this terminologies, we will be solving certain topics related to the graph, and these terminologies are very important to construct a graph and to solve the different techniques which are involved in graph. Okay, so thank you so much.